You know, every time we get on a plane, we're putting our trust in this incredible marvel of engineering. But what we don't see, what most people don't even know exists, is this invisible architecture of safety that's working tirelessly behind the scenes. Today, we're going to pull back that curtain on this secret blueprint that keeps modern aviation so unbelievably safe. Let's dive into the logic that makes it all possible. So just think about this for a second. How do you even begin to maintain a machine like this? A 500-ton beast with literally millions of individual parts, all working in perfect harmony. It sounds kind of impossible, right? Well, the answer is in this brilliant piece of logic that completely changed the game. All right, here's how we're going to break it down. We'll start with the old way of thinking, which was called MSG2. Then we'll get into the revolutionary new logic of MSG3. How it works, how it's actually put into action, and, the most important part, why this all matters to you and me. Okay, so every single aircraft needs a plan. And I don't just mean any old plan. I mean a super detailed maintenance program that guarantees safety and reliability for its entire life. The industry standard for creating this blueprint, it's a process called Maintenance Steering Group Logic, or just MSG. Now, to really appreciate the genius of the system we have today, we've got to look at where it came from. So let's take a quick look back at its predecessor, MSG2. It took what they called a bottom-up approach to keeping planes in the air. So the old philosophy, MSG2, was pretty straightforward. It looked at every single part and basically put it into one of three buckets. You had hard time, which meant you replaced a part after a set number of hours, no questions asked. Then there was on condition, which meant you checked something you could actually measure, like tire tread or brake wear. And finally, you had condition monitoring. This was for the non-critical stuff. Think cabin lights, where you basically just use it till it breaks. The key thing here, the focus was always on the individual part. And this, right here, is where the big shift happens. MSG3 wasn't just some minor update. It was a total revolution in thinking. It completely flipped the old model on its head. It shifted the focus away from the parts themselves and onto something way, way more important: the consequences if they fail.
So here it is, the fundamental difference. MSG2 started from the bottom, looking at each little component. But MSG3, it starts from the top. It asks a totally different question. Okay, if this part fails, what happens to the plane? This top-down, consequence of failure logic, well, it changes the entire game.
So how does this actually work in the real world? Well, the power of MSG3 comes from this really systematic two-level analysis that makes sure every single possibility is considered, with safety being the absolute #1 priority. Level 1 of the whole process kicks off with this one, simple but absolutely critical question. If something fails, would the pilots in the cockpit even know about it? Is the failure evident or is it hidden? The answer sends the analysis down two completely different pathways. So based on that first question, failures get sorted into these categories. If a failure is evident, meaning the crew can see it, the next question is about impact. Does it affect safety or just operations? Or is it only about economics? Now, if it's hidden, the question is even more direct. Does this hidden failure, either by itself or maybe combined with another one, affect the safety of the aircraft? You can see how safety is the filter for everything. Right, so once a potential failure is categorized, we move on to the second level of analysis. This is where a very specific, targeted maintenance task is chosen to prevent that failure from ever happening. And the task that gets assigned depends completely on the category we just identified. And this is the system's ultimate safety net. For any failure that could possibly affect safety, that's categories 5 or 8, the process is just incredibly rigorous. The analysts have to go through every single possible task. And if they find that no task can effectively prevent that failure, a redesign of the part is mandatory. Not suggested, mandatory. That is the non-negotiable backstop that puts safety above all else. So we've talked about the logic, which is kind of abstract. Now let's connect the dots and see how this all builds into a concrete, real-world maintenance plan that mechanics can actually use. This whole thing follows a really clear decision path. For any potential failure you can imagine, an expert group first asks, would the crew notice it? Then they classify the consequence. Is it safety, operational, or economic? From there, they just move down a checklist of solutions, from the simplest task all the way to a deeper inspection. And if no task can guarantee safety, boom, they hit that final mandatory step, redesign. It's a logical filter where safety always wins. So the result of all this intense analysis gets formalized into this key document. It's called the Maintenance Review Board Report, or MRBR for short. The easiest way to think about this is as the official government-approved blueprint. It's got all the mandatory maintenance tasks that an airline absolutely must perform. Then, the aircraft manufacturer takes that official blueprint, the MRBR, and turns it into the airline's practical playbook, the Maintenance Planning Data Document, or MPD. So, if the MRBR is the what, all the mandatory tasks, the MPD is the how. It's got everything from the MRBR, plus a ton of recommendations and crucial details, like man hours, so the airlines can actually build a schedule and get the work done. Okay, so we've gone through a lot of technical detail. Let's bring it back to the real world. Why does this smarter system even matter? Well, the benefits are very real, both for the airline industry and for every single one of us who flies. It really all boils down to three huge benefits. First, and most obviously, it puts safety above absolutely everything else with that consequence-first logic. Second, it makes everything way more efficient. By only doing tasks that are proven to be effective, you avoid a ton of unnecessary work. And third, it's flexible. It lets airlines tailor programs to each specific aircraft, which makes them more reliable and keeps operations smooth. And that kind of leaves us with a final thought here. This system is a true masterclass in how to manage risk. It forces us to stop obsessing over individual little parts and instead ask the bigger, more important question: what are the real-world consequences? So what if we took that same powerful consequence-first logic and applied it to other complex challenges we face? Just think about what we might be able to solve then.